Hi everyone, I'm Anna, mobile development expert, passionate about quality software and focused on Flutter from Ukraine. Some of you may know me as Anna Domashych. As if this name is not difficult enough, I have a bit of a personal update. I'm now Mrs. Anna Leushchenko. I am a GDE in Dart and Flutter and a senior staff mobile engineer at Tide. And today I suggest we talk about localizing Flutter applications. First of all, I should set the right expectation. This talk is not about comparing different existing localization implementations. It only aims to briefly describe why we should care about localization and what vocabulary we will be using today, my requirements for the localization approach, and the solution I came up with to satisfy them. We'll also implement it in the multi-language Flutter application. A big red disclaimer. This entire talk is referring to my own experience in creating and localizing Flutter apps. The approach I'm going to show plays nicely with other key components I typically have in my projects. It might not fit well in all Flutter projects, but I have already successfully implemented and tested it in several Flutter products. That is why I'm sharing it with you today. If you find similarities in how you and I approach implementing Flutter applications, chances are you might as well like how I suggest localizing them. Okay, so why care? App localization refers to the process of adapting the interface and functionality of a mobile application to suit foreign language markets. Localizing apps help make them relevant to a variety of cultures and languages, and provide an opportunity to grow businesses. All of us here aim to create high-quality software, right? Ideally, the localized application looks and functions like it was originally created for the target language. To achieve this, several aspects have to be taken into consideration. It is, of course, the language direction, left to right and right to left, date and time formats, but primarily the language itself. You have to translate all user-visible content. When it comes to localizing a Flutter app, there are 3 subtasks into it. The first and most obvious is to localize your UI. It can be texts that you have put in the text widgets, button labels, tab names, etc. The second, less obvious, is to localize Flutter widgets. For example, when user double taps on the text in a text field widget, a small pop-up appears with options to copy and paste text. Those little labels should be localized. Another example is Date Picker. It should have localized names for days of the week and months, and it also should use the appropriate date format. And finally, if you receive any content from the backend, be it goods description or conference speakers lineup, it is also subject to localization if you aim for a great user experience. Today, we are focusing only on the first subtask, but the second comes almost for granted, so we'll do that as well. A piece of advice from an experienced developer. Localization is one of those tasks you would want to tackle as soon as possible in the development. It doesn't take too much effort to gradually fill in a collection of words and phrases used all over the application in one or few places, as opposed to reviewing every single piece of UI for hard-coded values before the release. Okay, now that we hopefully agree on the importance of this task, but before we move further, I should briefly mention the vocabulary I will use today. Basically, we'll be moving from having hard-coded messages or translations directly in the UI to some kind of a translations provider. We would access a message by message key, and it is a responsibility of a provider to access some kind of translation storage or translation files. and use a translation key to obtain the correct message depending on the current device locale. Okay, enough of the introduction. Let's think about this. The talk title is Yet Another Localization Approach for a Reason. There are already plenty of solutions for any taste. Official guideline, several pub packages, various manual implementations. Some offer strongly typed message keys, while others leave you guessing whether a message exists and no refactoring support. Some use custom commands for generating code and don't offer a file system watching, while others imply only manual coding. They differ by supported file formats, pluralization support, a mechanism for locale switching, etc. So, why on earth did I need yet another one? Well, let's see what I was looking for. Translations should be stored in separate files, one file per each supported language. The format doesn't really matter. Something commonly used like JSON will do. I should be able to locate files anywhere in the project structure. The translation keys should be generated from translation files to Dart code during the development cycle. This way, I won't have to declare them manually, and I will have the auto-completion while coding, which will help me to make sure such a message exists. I don't have to remember the key name or navigate to a translation file to copy it. And I won't have a runtime exception if it appears to be missing. Also, I want Dart files to be regenerated each time a translation file changes. So the approach should offer file system watching. I think you might start to guess where this is going. When it comes to implementing medium to big size apps, using the package by feature approach is inevitable. So the ability to integrate the localization approach in each individual package is a must. And the last one is pretty obvious. The less effort, the better. As usual, there is a package for that. In my case, it is I69N by Tomasz Zvetina. Let's go back to the requirements and validate this package. Translation files organization. This package works with translations stored in YAML files. Each supported language has a dedicated file with an underscore and a special suffix in its name, consisting of a language code and .i69n. The default language file doesn't have to specify the language code. And files can be located anywhere under the lib folder. Check. Translation keys generation. I69N package works in combination with build runner. If translations.i69n.yaml contains greetings : hello world, after build runner build command is executed, a new file, translations.i69n.dart, will contain a declaration of translations class with a greetings getter that is returning hello world value. Check. File system watching. The build runner supports a watch command that runs a persistent build server that watches the file system for edits and does rebuilds as necessary. So each time there is a change in the YAML file with translations, a corresponding Dart file is regenerated. Check. Package by feature support. In the approach I'm going to show you, translations can be kept close to where they're needed, meaning in each package. Then, all pieces get connected together on the application level. Check. The less effort, the better. In my typical Flutter application, there are plenty of usages for code generation with build runner. I use a combination of freezed and JSON serializable for generating data classes. retrofit for generating API calls, get it and injectable to implement dependency injection mechanism, autoroute for navigation. We have already figured that an effective localization approach is impossible without some kind of code generation. So why use a different generating tool for localization if it is possible to apply the same build runner mechanism, which is already used all over the project? So check. In addition to satisfying core requirements, I69 offers a considerable list of additional features that are quite handy. String formatting. The package generates methods instead of just string getters if the string is intended to be used as a format. In this example, YAML file contains a declaration of password length validation error message that accepts an integer parameter. The generated translations file will have a password length validation error method that accepts the same integer length and embeds its value into a localized message. For pluralization support, you can specify different forms of nouns to be used depending on the amount passed as a parameter. In this example, homepage center text message accepts the integer representing how many times the button was pushed. The message calls the generated _plural function and passes time for a single push and times for multiple. Translation messages can still be accessed dynamically by a string key. In the generated Dart file, you will also find an index operator declaration that accepts a string and uses it in a switch statement to return a corresponding localized message. Translation classes nesting. Messages inside YAML files can be organized in groups. Previously, we had greetings being declared at the root of YAML file. In this example, it belongs to the general group. There is also a validation errors group with password length validation error. After the code generation is run, the Dart file declares 3 classes. Translations class contains 2 fields corresponding to the 2 groups from the YAML file: general translations and validation error translations. Inside general translations class, there is a greetings field, and inside validation error translations class, the password length validation error method. So the structure of YAML file is preserved. A nice side effect of using YAML files is that it does not allow duplicates. So you'll never have repeated keys or class names. This example will cause an error. Translation classes inheritance. Let's say the app supports 3 languages. English is the default, then French and Ukrainian. And thus, there are 3 translations YAML files. 3 corresponding Dart files will be generated. The default English file will contain translations class declaration, and other files will declare its children. This way, all classes have the same interface. Okay, this one is interesting. Whenever the translation file is changed, if build runner was run with the watch command, it will immediately update the corresponding Dart file. Next, when you hit save on any Dart file, Flutter hot reload in its turn will inject updated source code into the running Dart virtual machine, which will rebuild the widgets tree. Quite impressive, isn't it? There are a few particularities to keep in mind. It is a developer's responsibility to detect the current device language and select a proper translations class. And English has to be the default language. Now that we have discussed the why, time to move on to how. Today, we'll be localizing the mobile application with the schedule of this very Flutter Global Summit Volume 2 conference. The application has two tabs dedicated to two tracks, Junior and Senior. It lists everything: talks, breaks, Q&A sessions, panel discussions. User can navigate to the talk details and see the talk abstract, time, disabled Add to Calendar button, and can review speaker details. User can visit speaker social links and like the talk. By the way, likes functionality uses in-memory storage, so each time I run the app, likes count will start at 0. The app also offers basic search functionality. It filters talk by topic or speaker information on the fly. If we return to the localization subtasks, these cases would belong to localizing the UI. Break time, Q&A session, panel discussion, search toolbar, tab names, Add to Calendar button label, likes counter, and social networks tooltips. Date and time format is also subject to localization. There are only few Flutter widgets in this app that should be localized. One is the pop-up that appears when a user selects text in a search text field. And the second one is the back button tooltip. Now, this button tooltip is different from the search action tooltip because it is automatically provided by the Flutter framework with the up bar widget. There is no place in the code where I specify the back label for it. And the last one was about localizing content. In real-life applications, information about talks and speakers would be requested from the backend. In fact, this application uses hard-coded JSON as a data source, but I'm still going to treat it as something that comes from the backend. So localizing it is out of the scope of this talk. But just to give you a hint, content localization should be implemented on the backend side. And the mobile application would only inform it about the language it is interested right now. It could use request headers or other ways to pass this information with each request. So let's begin. Here I have my Android Studio with the application running in the simulator. Below, you see a list of commits I have prepared for today. We will walk through each of them, and I'll explain the changes they introduce. I start with adding the required dependencies. They are i69n and Flutter localizations. I will now update the dependencies and can actually run the code generation already. As I promised, the project already uses packages that generate code with build runner a lot. Here you see the freeze dependency, JSON serializable, injectable, auto-route, and now we have added i69 to the list. Okay. The next step is to provide the default language translations, which is English. Here is the translations.i69n.yaml file. I have grouped messages in various ways here to show you how to approach this. Messages in conference vocabulary are grouped by their meaning. Messages in buttons and tooltips are grouped by their usage in the app. Likes count doesn't belong to any group at all. So you can organize messages in a way that works best for you. Let's take a look at open social profile message. It accepts a name parameter, which is a social network name, and uses it inside the string. I don't want to localize the name, so Twitter or LinkedIn will remain the same no matter what is the device language. Likes count is interesting. It accepts the integer count parameter, and to compose the value, it calls the generated underscore plural methods and passes likes for 0 and many likes, and like for a single like. Now, because we have our code generation running, here we have already a generated translations.i69.dart file. It has a translations class, and inside there are fields for every group that we have declared in the YAML file. And likes count sits in the translations class directly, just as the likes count was declared at the root of YAML file. Let's check the open social network profile. It is a method that accepts the same string name and uses it in string interpolation. And the likes count calls the generated underscore plural function and passes the same parameters that were specified in the YAML file. Now I am adding translations to other languages, which is French and Ukrainian. As you see, the structure of the YAML files is similar to the default language. And here we have corresponding Dart files being generated. Okay, now that we have our translations in place, we have to use them in our widgets. But simply instantiating a translation class doesn't give much of an advantage. The translations class itself does not have the information about the current device locale. If you remember, I told you that it's our responsibility to pick the correct translations instance. It is done in 3 steps. First is declare and implement localization delegate. Second is connect it with the material app. And third, on a widget level, obtain localizations delegate instance from the context and use the provided translations instance. So, the step number 1. Here is a localization delegate implementation. I have app localizations delegate class that overrides 3 methods: is supported, load, and should reload. Is supported indicates whether resources for the given locale can be loaded by this delegate. And load actually loads the resources. When the device locale is changed, the material app will call this function to enable switching translations instances. The instance of this delegate is exposed in app localizations class static field delegate. App localizations also exposes supported locales static list. As you see, all these methods rely on this map of correspondence between the locale or language code and the translations classes. Okay, for step 2, I'm providing the values from app localizations class to the supported locales and localization delegates of a material app constructor. And the last step is to actually use the translations. To obtain an instance of the translation class from the app localization class, I'm declaring a static method of. It is similar to how we obtain a SIM data instance from the SIM of context method. Now I'm using this method inside the widget to access the text for the Add to Calendar button. Similarly, I am using app localizations everywhere in the UI where localization is needed. Okay, so now it looks like the app is localized, isn't it? Let's check. Well, nothing really changed for the English, which is pretty good already, right? And looks like if we run this application on the simulator, which uses Ukrainian language, we would expect it to be translated, right? Well, not really. Here, what we in fact see. So what has happened? When we didn't provide any delegate to a localization delegates array, the default values were used. Since we are now overriding it, we should explicitly include default delegates provided by the Flutter localizations package. Like this. So let's now check. Better, right? So we see the application is translated to Ukrainian, at least some parts which we actually expected to be translated, and something that we wanted to stay untranslatable remains so, like this LinkedIn title. And you will have to believe me, but likes counter is updating according to Ukrainian language rules. The back button is localized thanks to providing the default delegates, which I just showed you. One missing piece, though, is localizing the date and time formats, right? For that, I have created a build context extension that gets the language code with localizations.localeOff method and pass it to date format methods like this. Okay, cool. We see tabs, names, and time format was updated. One last thing. While using app localizations of context is already good enough, I'm declaring another build context extension called translations. It can as well be a method named localize or similar. And here it is used again to obtain the translation values. So now we have our app localized in 3 languages: English, Ukrainian, and French. Voila. Everything we saw today is already available on the GitHub. You can check the code and the slides at this link. And we are almost at an end now. But don't forget about the big red disclaimer I gave you in the beginning. This approach may not be the way to go for all Flutter projects, but it fits quite nicely in the products where code generation with build runner is already heavily used. And if you prefer consuming written content, this approach is described in details in the article with the same name, yet another localization approach in Flutter, published in Flutter Community Medium publication. I am now happy to answer your questions.
Yeah, sure. No, the session was very good, and we have some Q&A that I will just show you. Let me show you the question first. Okay, so what do you mean by saying that the English should be the default language?
Meaning that the application has to have some fallback in case the some language or device locale is not supported, and it should be English. That is the limitation of the i69 package. And to be honest, most likely we all develop with English in mind in the first place. So I didn't feel any like major discomfort with this limitation.
Okay. So let's move to another question.
Yes, of course.
Yeah, exactly.
The code is available on GitHub. Will be available just in a moment.
Yeah. Okay. Let's move forward.
Well, that is an interesting question. You can obviously do this manually. You will for sure have the default English YAML done while you are developing the application. And if your application is pretty small or easy enough, you can actually take this entire YAML file and put it in the Google Translate. It is pretty smart to not to modify the translations keys, but only translate the values. It may not work for all languages, but it is already something. But for big applications, most likely your team will cooperate with some content creators and translators. So you will have to give them the sources, like your English file, and get the translations from them and put it back in the project. So some level of manual work is unavoidable.
Okay, nice. Let's move to the last question. So how does IE16 compare the Flutter localization package used by the Flutter skeleton template?
If we take a simple like Flutter skeleton template application, which uses the only the one single package, the difference would be in the code generation mechanism. What I showed you today uses build runner mechanism, which is what I prefer to use because I have already a lot of other dependencies using it in the project. And Flutter localizations would use another generating approach, which is specifying generate true in the pubspec.yaml file.
Okay, I guess we have finished with the questions. Again, thanks a lot. The talk was really very awesome, and it has a lot of depth knowledge related to the translation, the making the multilingual your application and localization. So thank you.
It was my pleasure. Thank you.
Thank you. Take care. Bye.